In this video, I'm going to go over horizontally launched projectiles and just kind of the concepts behind it. So this is a soccer ball at the top of a tower. I don't know. And I have like this fantastic soccer player that's standing up here. Well, before when we were doing free fall, this soccer player would have just dropped the ball and it would have just gone straight down. But see, we're not talking free fall anymore. We're talking horizontal. So it's a little bit more fun because the soccer player gets to kick the ball. And let's say that this soccer player kicks it at about a 15 meters per second velocity. Now, the difference between this and free fall is that it's moving in a different direction now. It's still going to be moving down, but it's moving away from the cliff as well. So we set up a coordinate system to kind of help when we're talking about this. And right here is where my origin would be, right where this soccer ball is. So this is still the X and this is still the Y, just like in math class. But the key thing that you have to take away is that this object is moving in the positive X direction, but it's also moving down, which is in the negative Y direction. Because it's moving in two different directions, that's why it's called 2D direction, we are going to make an X and Y chart that helps us break down these components to just the X direction and just the Y. If you're looking at it as a whole, it's impossible to understand. But if you break it down into the X and the Y, it gets a little bit easier. I want to start by talking about the Y direction, because the Y direction is just like free fall. Literally, it's exactly like free fall. So this object, right at the instant that it's kicked, is not moving down. It's not going in the Y direction at all. It's just being kicked in the X direction. So that means that your initial velocity in the Y direction, which I like to show it like this, initial velocity in the Y direction is 0. Now I know that some teachers teach us a little bit more, a little bit different, and that's okay. Also in the Y direction, this is the part that's just like free fall. Let me write that on here. This is just like free fall. And in free fall, or anything that's moving towards the earth, the acceleration is going to be 9.8 meters per second. Now for us it's negative because it's speeding up and moving in the negative Y direction. Okay, so that's the basics for the free fall here. Now if this was a real problem, it would probably give you the height of this as like 5 meters or something. And if it did that, then that is your distance in the Y direction. So you would I put dy like this. Some teachers teach it as triangle Y. Either way is perfectly fine. And it would be negative because it is moving down. So it's moving in the negative Y direction because right here was our point of origin. Now let's talk about the X direction. This is the part that's a little bit new. There is no force other than that initial kick in the X direction that is causing this object to speed up or slow down in the X direction. Yes, there's acceleration in the Y direction, but there's not an engine on this soccer ball. There is not something pushing on this soccer ball while it's in the air. So what this means for us is that while our initial velocity in the X direction would be that 15 meters per second, that our acceleration in the X direction is 0. Whereas that negative 9.8 was acceleration in the Y direction, or you could write G for gravity. They're exactly the same thing. Now, D in the X direction would be the distance that it goes from where it was kicked to where it lands. Again, some teachers teach us as triangle X, and that's fine as well. It's just the change in distance in the X direction. Now, when you're given a problem like this, the most common thing is, to solve for distance in the X direction. That might be your unknown. But the only way that you can do that is if you realize that time. There is no X component and Y component of time. Time is just time. So if you solve for time on one side of this T-chart, it's the same number for both sides. And that's the key that you have to understand. The time is the only thing that can go from one side of the T-chart to the other side. So that'll help solve these problems. Now, before I do the next video on walking you through how to solve these problems, there's a few other concepts that you have to be familiar with. Okay, I've cleaned up my screen a little bit, and I can't clean it up even more because, for whatever reason. Some things that you need to understand is, let's say that this scenario right here where the soccer ball was kicked at 15 meters per second from some height, it took a time of 3.5 seconds. Okay, I'm just making up this number here. If the soccer ball was just dropped right here completely in free fall, that would also take 3.5 seconds. If it was kicked at a velocity of 30 meters per second and it traveled out here, that would still take 3.5 seconds. The reason the time doesn't change is because that initial velocity. If it's kicked at 30 meters per second, then it's going to start off super fast. So it's able to travel more in the X direction and in the Y direction at a faster rate, but it's still going to come out to be 3.5 seconds. If the object is just dropped, well, that initial velocity starts out as 0, so it starts out super, super slow and then starts to speed up. So you have to realize that no matter how hard the ball is kicked or just dropped, that if it's traveling the same distance in the Y direction, it's going to take the exact same amount of time. Now, the key point on this slide was to remember that if the ball was dropped straight down, let's say it took 3.8 seconds. If it was kicked at 15 meters per second, it would still take 3.5 seconds. And if it was kicked at an even greater initial velocity, it would still be 3.5 seconds. The other big takeaways was realizing that, and I've kind of erased it here, but acceleration, initial velocity in the Y direction is always 0. Acceleration in the Y direction is always the negative 9.8 meters per second squared. And knowing that your acceleration in the X direction is always 0 meters per second squared. These are big takeaways that you have to have memorized before you can solve any problem in horizontally launched projectiles. Okay, in this new drawing, I want to show the next concept that's big that you need to realize. I'm going to put the horizontal velocity in blue. So let's say the soccer ball was still kicked at a 15 meters per second initial velocity in the X direction. Because, as I said earlier, there's no acceleration in the X direction, you could pick any point in time on its projection, and that velocity in the X direction would still be 15 meters per second at every single case. So your initial velocity in the X direction is also your final velocity in the X direction, or your velocity at any point in time. Now let's talk about in the Y direction. In the Y direction, we said that your initial velocity would be 0 because it's just like free fall. And just like free fall, there is an acceleration, it's gravity. So what that causes is that at each point in time, your velocity increases just a little bit. I can't really say just a little bit, it could increase a whole lot. So your initial velocity is not the same at your velocity at, say, 2 seconds, or your velocity at 5 seconds, or your final velocity. Those numbers will be completely different. Okay, so just to recap, the biggest takeaway from this slide right here is that your initial velocity in your X direction is the same as the velocity at any point in time, because there's no acceleration in the X direction. Now your velocity in the Y direction starts out as 0 because it's not moving down yet, and at any point in time that velocity is going to increase because there is an acceleration in the Y direction, and that is negative 9.8 meters per second squared, which is gravity.